Hello, 7th graders. We're continuing our discussion here in number theory today when we're talking about multiples and divisors of natural numbers. Now, when you studied ordered n tuples, you'd say for every n that's an element of the set of natural numbers, you could denote the multiples of n by saying this big capital M with little subscript n here. So that is to say, this set that you see right here in braces, we could label that as the big capital M sub n. If I write M sub 2, I'd have this set. Can you guess what I'm about to write here for this one? Yeah, M sub 4. Now these, of course, are improper roster names, and recall the term improper roster is referred to, it refers to some kind of roster name where I just don't have the patience or ability to write the entire set. I use points of ellipsis at the end to say, yeah, this keeps on going. Now, as it says here, generally speaking, a whole number m is a multiple of n, or n belongs to the set of multiples of n, if and only if there exists some other whole number k such that m equals k times n. So, there is a video, I'll let you watch that on your own, where it talks about how to write prime factorizations. Prime factorization is going to be its standard name. Prime factorization of number p will be its standard name. Just leave it as that. Which is to say that, for instance, well, I'm just going to pull out 24 here because I happen to be talking about. I did this in class yesterday. You saw me talk about it. 24. If I was writing out the prime factorization of, it's 2 times 2 times 2 times 3. Alternatively, you could say 2 to the third times 3. Anyway, on exercise 19, let's talk about exercise 19 right now. And for each part of these, we're going to enter a roster name of the set of all solutions of the given statement. So that is when they give the statement 12 as an element of multiples of n, where n is an element of the set. And yeah, we can list out 1, 2, 3, 4, 6, and 12, because if I listed out multiples of 1, I would have 12 in there. If I list out 2s, it would have 12 in there. 3s would have 12 in there. 4s, I go 4, 8, 12, and yeah, there it is. 6, 12, 18, yeah, sure. And obviously the first multiple that's other than, if I was listing multiples of 12, I guess you could technically say 0, but it's not terribly commonly used, of course. It's kind of academic. Now, let's go on to multiples of 13. Wait a minute, not multiples of 13, rather multiple sets where 13 is an element. So don't start telling me 13, 26, 39, no. Rather, what I want to do here is say 1, comma, that's a terrible comma. I can do better. 1, 13. See? For 21, and carefully, getting the idea that 1's going to be part of it too, because if I list out multiples of 1, I'll have 1, 2, 3, 4, 5, 6, and eventually I'll have 21. So in fact, here, spoiler, they'll all start with 1, won't they? And yeah, of course, if I listed 3s, 3, 6, 9, 12, 15, 18, 21, yep, I'd get there. If I did multiples of 7, 7, 14, 21. That's relatively simple. All right, so when you get to exercise 20, now you're writing the divisor sets of these names. These look suspiciously similar to the very numbers up here on 19. I'll let you figure out what that means. So finally, here we get to something I introduced yesterday. When I talked about these number of divisors here. So a number of divisors of 6 would actually have 4 of them, but so would 10, so would 15, so would 21. Notice the prime factorization of each of these is just the first power of 2 different primes, and that's it. So with that, armed with that piece of information, give 5 other natural numbers where the number of divisors for that number n would equal 4. Now, as I said up here, people frequently lose points on this because they'll forget 6, 10, 15, or 21 were in the direction. So you don't put 6, 10, 15, or 21, or you're going to lose points. And don't ask me to reset this one because you put 6, 10, 15, or 21 as one of your answers on the exercise. Because then I'll know you didn't watch this video. But congratulations to those of you who did. Folks, I want you to complete exercises 18 through 28 on pages 7 through 13. You should ensure all 28 exercises assigned to this point have answers entered by next Wednesday. I will see you in